Okay, now that all the questions are done, just going to go over a few things about like checking or confirming or understanding what's going on. So the first bunch of examples, I think it was 13 to 22, we were just dividing using synthetic division. Make sure that you set the divisor equal to 0, and you should get this as your answer. That number is what goes in the box. If you put the wrong number in the box, the whole problem's wrong, okay? Like, whatever stakes we have to make this so that you don't do that, just tell yourself you will get 0 points of credit, no matter how correct all the work is, if you put this wrong number in this box over here, okay? This is how important it is. You ruin the entire problem if you don't do it correctly. I need this to be important, okay? High stakes over here. That's the factor that we're looking at, x minus 1, and we divide using 1. We set this equal to 0. That's the number that goes right over here. If you use the wrong number, wrong, all of it, goodbye. Not even worth checking, okay? So please do that correctly. Now, the remainder is 0. We put in the coefficients. We didn't need a placeholder. Side information, I'm going to point something out about each example. So this one over here, normally if I had asked you to factor this, okay, you would have been able to factor this in prior units. How would you do that? This is something you would have factored using grouping, okay? X to the third plus 3x squared minus x minus 3. Do you see that ratio of 1 to 3, 1 to 3 again? So if you had done some grouping, you would have taken out an x squared from the two of these as the greatest common factor. Again, this step, I made it very bold in one of the problems when I was doing it. That's minus, so you have to take out a negative 1, all right? It's not just 1. That is crucial. When you're not doing that, you're messing up the entire problem, okay? Then you bring out front your GCF, what's left inside. We'll figure that out in a second. You bring out the other GCF out front. What's inside, we're about to find out. I call it the pretzel when I divide, just to reiterate that, all right? For anyone who is rusty or shaky at factoring still, you got to find the time, you got to practice, okay? That would divide to x, and that would divide to 3, positive 3. Here, this negative is important because it'll mess everything up here if you don't include it, and again, you'll get an x plus 3. These should match, and they do. I factor out an x plus 3 because now that's my GCF from that guy and that guy right there. If I factor it out, what's left inside? When grouping work, it's because you have a sum or a difference of 2 squares, more than likely, depending on the problem, all right? X plus 3 stays as is. It's already linear, therefore it's prime. X squared minus 1. By now, you should recognize without any issues that that's a difference of 2 squares, and we factor using conjugates. The square root of x squared was x, and the square root of 1 is 1. Conjugates mean you have the two of the same factors, one's plus and one's minus in the middle. We keep the beginning, and we change that ending. So we could have factored it like that. Now, what does that tell me? If I'm dividing by x minus 1, which is right here, okay, that's what I'm dividing by, then this is my quotient. This is what I got as my quotient. Well, that's just this expanded. This is factored form and expanded form of the same expression, okay? So just to highlight, those are the same exact expressions, okay? Now to talk about another example here, maybe I won't go into this one. Actually, we could compare a little bit. This one here also had a remainder of 0. However, this would not have been able to be factored by grouping. To factor this, we'll use something called the rational root theorem, but the rational root theorem will require essentially this step of synthetic division. So that's why we learn how to use synthetic division. This right here, while it might look factorable, AC method, 1 times 2 is 2, what multiplies to give you 2 and adds to give you negative 2, nothing. This piece here is not factorable. This is going over some vocabulary, going over some important stuff here, this is a prime quadratic factor. So if you were asked to factor this entire thing, well, what would the factored form be? Factored form, you're essentially there. Your factored form is the x squared minus 2x plus 2, x squared minus 2x plus 2, and the x minus 2. Since this is prime and this is prime, you're essentially finished. If you are asked to solve something like this thing up there, okay, that set equal to 0, okay? If we were asked to solve this as if it were set equal to 0, or really initially that, okay? You would get down to, you'd factor as far as you can. Factor as far as you can. Now, this should have up to 3 answers, up to 3. Here, I'll get one real answer. I'll set that equal to 0, 0 product property, I'll get 2. But what do I use on this if I cannot factor it? What do you use on that piece to solve? Hopefully, everyone remembers, we use the quadratic formula, and you go from there, okay? So quadratic formula, okay? might not be a bad idea while we have the opportunity to do a quick refresher of quadratic formula. So anyone who's watching, you'll have an advantage. So quadratic formula is x equals negative b plus minus the square root of b squared minus 4ac all over 2a. The a value in this case is 1. B is negative 2. I know you can't really see. Blue wasn't really the best choice for a highlight color. And the c value is positive 2. All right. You do not use the x's. All right. If I see that, I'm going to lose my mind a little bit. I guess I could squeeze this in and work on it. Why not? So let's kind of branch him off a little. Okay. So if I fill these values in, the plus minus indicates we're getting two answers. One will be using this operation with the plus. One will be using this operation with the minus. I will get opposite of b, which is positive 2. I'm going to skip a few steps. Plus minus the square root. If you don't understand, just hit pause, write it all out. You should be good. B squared is negative 2 squared, which is 4 minus. Now, a times c is 2. 2 times 4 is 8. So really, it's just 4 minus 8. This is interesting talking point. All over 2 times 1, which is 2. 4 minus 8 is negative 4. So I have, again, x is equal to 2. Again, it's all over this fraction mark. Do not cross it to the other side of the equal sign. All right? It's underneath the whole entire thing. It will not divide by, or into rather, these things, or by the discriminant or radicand independently. It is underneath the entire numerator, so we will cross that bridge when we get to it. Plus minus the square root of 4 minus 8 is negative 4. Now, if you have some good reasoning skills, you're going to say, well, no real solution, I'm done, because you can't take the square root of a negative number. Now, maybe you already learned about them, and maybe you did not, but there are things called imaginary numbers. So you would treat this radical like any other square root, except this negative inside, which is really attached. I don't really like that. I just blended that into the 4, sorry. This negative, which is really a negative 1 times 4, the square root of negative 1 is equal to something called I, the imaginary unit I. So the square root of 4 is 2. For lack of time right now, I'm just going to say we're going to write 2 plus minus 2 imaginary, 2i. I like to usually for I curl it and really dot it because it's going to start looking like a 1 all over 2. Now, I've stressed this silly pretzel since the time we started factoring, okay? This pretzel is important here again. You do not just cross out these 2's and call it a day. If you do that, wrong. Whole thing. No credit. You don't deserve any, no matter how right this is. Do not do that when you're in Algebra 2 at this point anymore. If you are using synthetic division, you can't make that mistake anymore, okay? Off the table. No points, no partial credit. It is wrong. So you can reduce like this. You cannot just cross out a 2 and call it a day. So what does this give us? 2 over 2. That equals 1 plus and minus. 2 over 2 is 1. 1 what? 1i. So we have two answers right there. Oh, I'm sorry, I'm cut off. 1 plus I, 1 minus I. So we have two answers. This is a sneak preview of stuff to come. And the other answer we would have gotten from this right over here, it would have been x equals 2. We would get our three answers. 1 is real, and 2 down here are imaginary. But that is actually our next topic, is imaginary numbers, and then we'll loop it all back together. What's over here? Oh, here, the other day we went over, when we did long division, I showed you some tricks about checking your answers. So this number that goes in the box, right, that I'm going to be very strict about, this number, negative 4. If you put positive 4 here, the whole thing's wrong, you get no credit, okay? But negative 4, that goes here, if you plug it into this, the numerator of the function, or the dividend, if you will, if you plug it into this, you should get your remainder of negative 28. And if we do, it's correct. So let's check it out doing that. So we have negative 4 to the third minus 7 times negative 4 to the second minus 7 times negative 4 plus 20. Negative times a negative is positive. 7 times 4 is 28. 28 and 20, that was positive, remember? 28 and 20, that's positive 48 for the two of those. 4 squared is 16. And 16 times 7 we have over here. And then this over here is negative 4 to the third. It's negative 64. Ooh, actually, weird things I do when I do math. So I'm going to kind of let you into my strange mind for a moment. So I have them at this step right over here. Negative 64 plus 48. That's negative 16. So follow me over here for a moment, will you? So that right there we just said is negative 16 minus 7 times 16. Well, I have a GCF of 16 right now because I don't feel like doing 7 times 16. Why? Well, just because I don't want to. So if I factor out a 16, okay, even actually, I could factor out a negative 16. So I'm going to go right there. Well, what's left inside? If I take a negative 16, it's not 0. If you do that, shame on you. It's 1. And then that becomes positive 7. Now, 1 plus 7 is 8. So now I have negative 16 times 8. And multiplying by 8, you double something 3 times. 2, 2, 2 is 8. So times 2, 32. Times 2, 64. Times 2, 128. And a negative times a positive is negative. So sweet deal right there. That means if this was written as f of x, f of negative 4 equals negative 128. Now, here's the catch. Or, another perk, if you will. Sometimes this, I think, was difficult. I think getting negative 128 here was easier. So sometimes when I need to plug in a number like negative 4 into a polynomial, I'll do synthetic division on the side and just find my remainder. Other times, if I just need my remainder, I'll just plug in. It depends which one's easier, okay? Usually if I have to plug in a number like a 4 or 5, even 3, I'm probably going to go ahead and use synthetic. It's probably going to be easier. If I'm plugging in a number like 1 or dividing by x plus 1 or x minus 1, well, then really plugging in could be just fine instead of synthetic division, okay? Both of these examples, grouping would not work to factor, so you would need some synthetic division support to continue. This quadratic is prime. Nothing multiplies to 5 and adds to 2, so you would stop right there. This does factor further, so if we did need to factor, we could continue. What multiplies to give you, well, 1 times negative 6 is negative 6. What multiplies to give you negative 6 and adds or subtracts to give you negative 1 would be negative 3 and 2. So when all is said and done, that right there, not that we needed to, is equal to an x minus 3 times an x plus 2. That's just this part of it. This is another factor, the x minus 1. Well, I shouldn't have written like that. So actually rewind because that looks like a y. So the answer is equal to that, right? The answer is equal to that. But this, x to the third minus 2x squared minus 5x plus 6, well, what's that equal to? That's equal to x minus 3, please use parentheses, x plus 2, and x minus 1. All 3 multiplied, x cubed should make sense. So cool tricks that synthetic division can provide for us every once in a while. And if you think about it, without learning rational root theorem yet, if it's factorable, look at this nice number 6 at the end, right? We've talked about this before. The first. If you multiply all your first terms, it will equal this. Paying attention to your multiplicities, of course. Same with the last. Negative 3 times 2 times negative 1. Well, that's positive 6. So when we're doing this thing called rational root theorem, you're going to be using your first and last terms to help you figure out some numbers to test out with division to work on getting this whole thing factored. What else can we see here? Again, if I plug in a number, I would plug in negative 2. If you have a 2 here, shame on you. Do not do that. Common mistakes I see here, when your leading coefficient isn't 1, by accident people put a 1 here. So just watch out for that. You don't want to make that mistake because people get into a habit. You bring down the first number. Also, this over here, the last number is always your remainder, and then your powers kind of go up from there. You'll have a remainder, a constant. What's after constant? Linear. What's after linear? Quadratic, and so on. Another way to think of it is it's cubed divided by first power. Your answer will be second power. When you divide, you subtract exponents. Here was our first example where we did need a placeholder. We did not have a linear term, so I just filled in a 0x and put that 0 there. The same goes for when we're dealing with long division, okay? Here, another factor. This might be factorable because I'm seeing 3 times negative 3 is negative 9. Let's do a little AC for practice. So 3 times negative 3 is negative 9. What multiplies to give you 9 and adds or subtracts to give you 8? Well, 9 is 1 and 9, or 3 and 3. And 1 and 9 looks pretty nice. Positive 9 and negative 1. So yes, this is factorable. For those of you who try to take cheap tricks and you think it's something like just minus 1 and plus 9 in your parentheses and you're done, please, all right, that is not what's going on. No one showed you that. That doesn't work. It only works if your leading coefficient, your A in a quadratic is 1, but otherwise it doesn't work. So please stop using that. From here, if you did want to continue, if you just need some more practice with factoring, you feel free to double tap and continue, fast forward, whatever you need to do. But I'll have 3x squared minus 1x plus 9x minus 3. And then I'm going to use grouping. So x over here and a positive 3 here. Take out the x, pretzel division, plus 3 comes out front, little pretzel division. Divide it out, I get myself some 3x minus 1 and another 3x minus 1. I can't say this enough. If these don't match, it doesn't factor or you messed up. It is not 2 different factors. Saying it again, if this and this don't match, you either messed up or it's not factorable. These are not factors. Fix it or move on. That is my common factor, and that's why it could come out front, all right, because it's a GCF. And then I have x plus 3. Since that is equal to that, let's color coordinate a smidge. So with orange, that is equivalent to that. But we also have the original factor we divided in That can get written as well, and that's equivalent to the entire original. So this is the x plus 3, and that is equal to, that numerator, if I expanded, 3x to the third, which I don't feel like doing, 17x squared plus 21x and minus 9. Okay, lovely. Now this one, big time. This is important, okay? Hopefully somebody out there recognized this situation. X cubed plus 27, we dealt with this a while back, not too long ago, but in the earlier unit, when we were factoring x to the third plus 27, this is the sum of 2 cubes. And when we dealt with this, I told you make sure you put on your cubing glasses. All right, we're going to put on our cubing glasses. So, sunglasses, okay, and the earpiece. If we put on our cubing glasses, we're asking ourselves, what's being cubed to make these? Maybe your glasses look more like this. Lovely. What's being cubed? X. What's being cubed? 3. Then we factor. We get a linear and quadratic factor. This linear factor, we take those 3's, we put them in our pocket, we save them for later. What's left? Just x plus 3. We'll deal with these 3's now. We're going to sprinkle some magic dust, okay? What's x times x? X squared. What's x times 3? 3x. And what's 3 times 3? 9. Then we use our little mnemonic device, our SOAP, which stands for same, opposite, same as the original problem, opposite from the original, and always plus. So this is the factored form of that right there. If I divide this by, this is my long division bar, ignore that SOAP writing, but if I divide by x plus 3, fractions are division, that's division, that's division. If I divide by the x plus 3, well, I have a matching factor on top and bottom. This is where you are allowed to simplify or reduce, and your quotient will be this piece over here, x to the second minus 3x plus 9. Coincidentally, there it is. So if you notice you have the sum or difference of cubes, well, make sure you get these right when you're asked to do division, long or synthetic, whatever it may be, okay? Make sure you start to see these connections. Don't take advantage of me just showing you, but definitely take your time to really wrap your mind around it. Okay, and then this over here is just that mixed number form of something that didn't divide evenly. If we wanted to check it, because it is possible to make a mistake, if I plug in 1, not -1, again, if you do the wrong number here or with that check, no sympathy, okay, no credit. So I'm going to go over here, 6 times 1 squared minus 8 times 1 minus 2. 1 squared, also, please, this is not 6 squared, right? Don't be a weenie, don't make that mistake, because PEMDAS, right? So that's going to be 6 minus 8, which is -2, minus another 2. As much as you want that to be 0, it is in fact -4, which confirms we are correctamundo. Next thing we got here was essentially articulating something that I was just going over in the checks anyway. So here is a polynomial. We graphed polynomials in our previous unit, and here we have polynomial and a given factor. That means if I divide, the remainder must be 0. Now, we are asked to use synthetic, so I did. I got this right here, but then it says use the given factor to completely factor each polynomial. So that means I can factor that further. For a bonus, I asked you to graph, okay, for a bonus step. This right here, factors, hopefully a lot of you can get right to this without showing all the work at this point, but if you can't, then show it. That's it, completely factored. From there, we use our other little trick, that silly mnemonic device I gave you, funky zebras. Enjoy pink marshmallow goblins. Funky, oop, let me cut off now. Funky is factor, done. Zebras is zero product property. What did I get? X equals 2, -3, and -1. Check. Enjoy and behavior. Go back up here. Stop doing your end behavior from factored form. It's positive and odd. So it finishes up, starts down, down and up. Check. Pink is plot. Plot those zeros from the zero product property step. And also plot your end behavior. Marshmallow, multiplicities, they're all first power, so all of my zeros will be cut through, quite linear in shape. Check. And graph. So I completed the whole thing. Polynomials are smooth and continuous. Last but not least, we had the other example, which was essentially the exact same thing. So this should be a little smoother looking, but, you know, humor me. I was drawing it, I was trying to stretch it out a bit, and hopefully that clears up any concerns.